All right. So good morning to all of you. Last session we began with a new chapter, Unit 3. The title of the unit was Feedback Amplifiers and Oscillator Circuits. Okay. So very quickly we'll just go through the recap of what we had done in the previous class, and then we'll continue further. Okay. So we just looked at the contents. So it's broadly divided into two sections. The first one will focus on feedback amplifiers, wherein we'll try to understand the concept of feedback, the feedback different connection types, and then what is the main effect of negative feedback on gain and bandwidth parameters. Okay, then we'll focus on oscillator circuits. Okay, oscillators are mainly based on positive feedback, so we'll understand its operation, and we'll try to focus on different types of oscillators with respect to FETs. Okay, so we have wherein we have phase shift oscillators, Wien bridge oscillator, tuned oscillators, and so on. Okay, yes. So we had discussed about the feedback concept. Okay, what do we mean by feedback? Okay, and what is the usage, and what are the benefits of feedback? See, in general sense, taking a small portion of the output signal and then feeding it back at the input is called as feedback. Okay, now feedback could be positive or it could be negative. Okay, so that was the simple block diagram of a feedback amplifier, wherein there are two main important blocks. Okay, so the first block, which is triangular in shape, is the amplifier. Okay, so at the output side, taking a portion of the output signal and then feeding it back through the feedback network by means of the feedback parameter beta, you will be getting the feedback signal. Okay, so at the mixer side, okay, that's the mixer. At the mixer side, you will be getting the feedback signal, which is either in phase or out of phase with respect to the original input signal Vs. Okay, so if both of them are in phase, we call such type of feedback as positive feedback. Okay, so I'll just write in short, if both of them are in phase, then we usually call it as positive feedback. If they are out of phase, then we usually denote the feedback as negative feedback. Okay, so the same thing is being discussed here. If they are out of phase, then it is negative. If they are in phase, then it is positive feedback. Okay, then we also discussed about some of the important features of negative feedback and also positive feedback. Okay, so negative feedback has more properties, more beneficial points when compared to a positive feedback. So what are the beneficial points of negative feedback? Higher input impedance. Okay, that's the most important point. Then better stabilized voltage gain, right? Improved frequency response, lower output impedance, and then the reduced noise. Okay, then further, more linear operation. Positive feedback, since the feedback signal and the input, both of them are in phase, so it is quite obvious that as the number of feedback stages goes on increasing, the positive feedback drives the circuit into oscillations. So that was a nice exhaustive comparative chart which we had seen yesterday. Okay, all right. So today we will be focusing on the different feedback connection types. Okay, so basically there are 4 feedback connection types. Okay, what do we mean by feedback connection types? That means the way we connect the feedback signal to our original input signal, that can be done by 4 ways. Okay, which means either we can consider the voltage or we can consider the current as a feedback unit at the output side. Okay, and then feed it back to the input either in series or in parallel. Okay, so which means altogether we have 4 possible ways of connecting feedback signals, right? So let us try to discuss those points. So what does the statements say? Both voltage and the current can be fed back. Yes. So you can either take the voltage or the current and then feed it either in series or in parallel. Okay, so that gives us with 4 possible options. The first one is called voltage series feedback. Okay, the second one is called as voltage shunt or parallel feedback. Then the third one is called current series feedback, and finally the fourth one is called as current shunt or parallel feedback. Okay, so altogether we get 4 such feedback combinations. What are the main features of these things individually? Okay, let us try to focus. What do we mean by voltage? See, if we focus on the first feedback, okay, there are 2 terms involved. The first one is voltage and the second one is series feedback, right? So what does voltage mean here? Voltage refers to connecting the output signal as input. Okay, please understand, voltage refers to connecting the output signal as input to the feedback network. Okay, so we'll just try to relate that point here. If this is the amplifier and if that's the mixer, okay, Vs is the original input signal and Vi is the relative input voltage which is being fed to the amplifier, and this has to be the feedback voltage. This feedback voltage comes from the feedback network. Okay, and that's our voltage, output voltage V0, and we'll be taking a portion, okay, either partly or completely the output signal and then feeding it back here. Okay, so that's the simplistic way of representing a block diagram of a feedback circuit. So now what does the term voltage mean? Okay, the voltage refers to connecting the output voltage, right? So what's the output voltage here? V0. V0 as input to the feedback network. So V0 is being fed to the feedback network. Okay, so that's our amplifier and this is our feedback block. Okay, so output V0 is in turn being fed as input to the feedback network. Okay, then the second one, what does current mean? Current refers to tapping of some output current. Okay, please understand, right? Whenever we say current, we are not extracting voltage from the output side, we are extracting the output current I0, okay, through the feedback network. Similarly, what does series refer to? Series refers to connecting the feedback signal in series with the input signal, right? So series means both the input Vs and the feedback signal Vf should be in series. Okay, which means I can just add them up, Vs plus Vf. What about shunt? Okay, shunt refers to connecting the feedback signal in parallel with an input current source, right? Please note that whenever they are in series, okay, whenever the input signal and the feedback things they are in series, we usually consider the term voltage. Okay, if we are concentrating on the parallel network, then we are focusing on the current source. Okay, so these things will be made clear to you in our next slides. Okay, so let us just focus on the first type, which is voltage series feedback. Okay, please note there are 2 terms here. First one is the voltage and second one is series feedback. Okay, so let's try to relate these 2 terms in the block diagram which is presented here. Okay, so this block diagram represents a voltage series feedback. Okay, so let us try to focus on individual parameters. Okay, so this block is for the amplifier. Okay, then the below block is for the feedback network. Okay, then things will be simplified for us to understand. All right, so what is the gain here? Gain A is given by output voltage by input voltage. Okay, as simple as that, right? Where Vi is the relative input voltage, and this Vi is the relative difference between the original input signal Vs and the feedback voltage Vf. Okay, if they are in phase, then both the voltages will be added and then given to the amplifier. If both of them are out of phase, then it will be subtracted and then given, which means, in short, let me just write, Vi is either Vs minus Vf, or it is either Vs plus Vf. Okay, so it all depends on what type of feedback we are giving back, either it is in phase or out of phase. All right, then so gain A is given as the ratio of output voltage upon input voltage. Okay, now can you tell me what is the unit of this gain parameter? See, V0, its unit is in volts, Vi unit is in volts, so both of them just cancel, so that the unit which we get is, it has no unit, it's a constant. Okay, so you should understand this. Here, for voltage series feedback, okay, the gain A is unitless or dimensionless. It is just a quantity, okay, unitless, right? All right, so now what does this term voltage mean? Okay, please understand, the first term is voltage. It associates with respect to the output side. Okay, so what am I extracting here? I am trying to take the voltage across the resistor RL. See, we usually take the voltage across the resistor, right? Okay, so the same thing is being done here, right? So due to which we associate the term voltage. I repeat, okay, we are extracting the potential difference across the resistance RL, okay, by taking the voltage. So this particular voltage is being fed as input to the feedback network. Okay, now all right, so what about beta? Beta is the feedback parameter. It is again the ratio of output upon input. Now for this feedback network, the output is feedback voltage and the input is the output voltage. Okay, please understand, right? Okay, so the voltage which comes from this end is input for the feedback network, and that is nothing but V0, right? And the one which goes out, okay, the voltage which comes out from here is the actual output voltage, which is the feedback voltage, Vf, and Vf is nothing but beta multiplied by V0. Okay, now this feedback voltage is in series with the original input signal Vs. Okay, I repeat the term, feedback voltage is in series, okay, with the input signal. Due to that, we are using the term series feedback. Okay, so I hope this explanation is clear, right? The first term is associated with respect to the output side. Okay, we are extracting the voltage and giving it as feedback to our feedback network. Then the second term is the output voltage obtained, which is Vf, is fed along with the original input signal in series. Okay, so I think this explanation has cleared the most of the things now. All right, so let us look at the next thing. What do we mean by voltage shunt feedback? Okay, so this is either shunt can also be written as parallel feedback. Okay, so now please focus on the first term, voltage. So this must always be associated with respect to the output across the resistance RL. Okay, so just look, is it correct? Yes. We are again taking the output voltage across the load resistor RL. So because of which we associate the term voltage. Then the output of the feedback. Okay, the output of the feedback is connected in parallel, or it is shunted with respect to a current source Is. Okay, please note here we are not representing it as Vs. Okay, Vs is the original input source. Okay, it's a voltage source, but for voltage shunt feedback, okay, now the feedback we are taking only the current out of it. Okay, we are not interested in the voltage. So If is the feedback current. It can be represented as beta into V naught. Okay, now this feedback current is in parallel with respect to the input current, which is Is. Okay, and input current can be represented as input the current source. Okay, so you can just observe Is and If both are in parallel. Okay, and finally the input current, the real input current I subscript small I, is in turn fed to the amplifier. Okay, so just observe now, the amplifier gain of voltage shunt feedback is given as the ratio of output voltage upon input current. Okay, see, this point should be very clear for you, right? Let me just compare this parameter with that of the previous voltage series feedback. Okay, what is the expression for the gain here? The gain parameter is given as A equal to the ratio of output voltage upon input voltage. Why? Because the output was a voltage and the input is also a voltage here. Okay, however, in voltage shunt feedback, the output is a voltage whereas input is a current. Okay, then obviously the gain should be output by input. But what about the unit? Is it dimensionless? No, because output is in volts and output voltage is in volts and input current is in amps. So it's like voltage upon current gives us the unit of resistance, right? Okay, V upon I is nothing but the resistance. So here the unit for A is in resistance. It is not dimensionless, it has dimensions. Okay, resistance dimension. Okay, so that's the gain A, right? Okay, then similarly, what about the dimension or the unit for feedback factor beta? It is again the ratio of the feedback current divided by the output voltage. Okay, so what is current upon voltage? Current upon voltage is nothing but conductance. Okay, so I just write unit for beta is conductance here. Okay, so that's the unit of beta. Okay, now so that was all about voltage shunt or voltage parallel feedback. Now let us just focus on the third type. Okay, see, if I just compare the first feedback connection type, if I call this as feedback connection A and the next one as feedback connection type B, right? What is common here? The common term was voltage. Okay, at the output side we are taking voltage. Okay, the uncommon term or the difference term was parallel and series. Okay, now the third case, it should be current series feedback and current shunt feedback. Okay, the third and the fourth ones. So let us just look at the third one. It says current series feedback. Okay. Please understand that the common blocks are the same. Okay. There will always be two blocks. The first one is the amplifier section block and the second one will be your feedback block. Okay. But the important point is, what is the gain parameter? Okay. The gain parameter depends on the type of the feedback, the type of the input and the type of output. Okay. So for current series feedback, again, the first term current must be associated with respect to the term across the load resistance RL, right? So now we are not interested in extracting the voltage, but we are interested in the current which is flowing across the load resistance RL. So that is I naught equal to IL. Okay, IL is nothing but the current which is flowing through RL. Okay, so now the same current will be flowing and it is fed as input to the feedback network, okay, which is I naught. Now what about output of the feedback network? Okay, so now the feedback is in series. Okay, we are taking we are providing feedback in series with respect to the input signal. Okay, so now just observe. So this is Vs, the original input signal, and the feedback voltage is fed in series. Okay, fine. By the way, what about the units now? The units for gain, it is current upon voltage, so it is conductance. Okay, the gain parameter is associated with respect to conductance. What about the feedback factor? It is voltage upon current, so the unit is resistance. Okay, if they are complex terms, then instead of resistance it will be impedance, and instead of the conductance it will be admittance parameter. Okay, so you can just correlate these things to your network analysis concepts. Okay, if you have already studied those aspects, the simple terms and the complex terms. Okay, all right. So that was about current series feedback. Then the final one is current shunt or parallel feedback. Okay, so here the input as well as output things are in parallel. Okay, the current the voltage, not the voltage, here it is the current term. So let us just observe again the gain parameter A equal to the ratio of I naught upon II. So here the output is a current, the input is also a current source. So what about the unit? The unit is dimensionless gain. Similarly, so we are interested in taking the current and then giving it as feedback to the feedback network, and the feedback voltage we are not so the feedback is being given in parallel to the current source. Okay, so we are not extracting the voltage, but we are interested in the feedback current. So feedback current is given as the product of beta into I naught, so that beta is again IF upon I naught. Okay, so please understand the first term IF is always the input term for the feedback network, and I naught is the output term. Sorry, it's again IF upon I naught. Okay, so what about the unit here now? The unit is again dimensionless. The unit is again dimensionless, right? Okay, so now just to summarize all the four of them, right? So here also it is again IF upon I naught, so it is output upon input. So just to summarize, the gain, feedback and gain with feedback. Okay, So let's try to focus on these three terms. So gain without feedback is being expressed by the term capital A. The feedback is beta, and gain with feedback is capital A with subscript small f. So AF stands for the gain with feedback. So for voltage series, voltage shunt, current series and current shunt. So for all these four feedback connection types, these are the corresponding expressions for gain, feedback and gain with feedback parameters. Right? Now what is the significance of these feedback connection types? Okay, see for practical applications there may be a need, okay, wherein we will usually prefer a very high input impedance, okay, extremely high input impedance, okay, and at the same time we may prefer an extremely low input impedance, okay. So this may be the requirement of a particular amplifier, right, okay, depending upon the application. Or there may be a case when we may need a high input impedance and also a very high output impedance, okay, or sometimes low input impedance and high output impedance, okay. So depending upon such requirements or the scenarios, we will be using that particular feedback connection type, either a voltage series, voltage shunt, series current series or current parallel feedbacks, okay. So the same points have been given here. Series feedback connections tend to increase the input resistance, okay, whereas shunt feedback tend to decrease the input resistance, okay. So now it all depends on the requirements, okay. What does the end user need with respect to the amplifier? Similarly, voltage feedback tends to decrease the output impedance, whereas current feedback tends to increase the output impedance, okay. So I'll just be writing increase the input resistance. It is either Ri or Zi, okay. If it is resistance, then it is Ri. If it is impedance, then it is Zi. Whereas shunt feedback connections tend to decrease, okay. So here there is an increase, and whenever the feedback is parallel, it will be reducing, okay, impedance will be reducing. However, okay, it is being mentioned that typically means usually or generally higher input and lower output impedances, which means higher Zi, okay. So this upper arrow indicates higher Zi and lower Z0 impedances are desired for most cascaded amplifiers, okay, single stage or maybe double stage amplifiers. These usually prefer a higher input impedance and a lower output impedance. So both of these features can be provided using a voltage series feedback connection, okay. So what does that mean? Out of these four feedback connection types, the most popular one, the most useful one, the most practical one is voltage series feedback connection type, okay. So which I'll just highlight it here. The voltage series feedback is the most popular one, okay. And please understand that that does not mean that other configurations, other feedback networks are not useful, okay. They are also equally useful but not so popular, okay, fine. So maybe in the next class we'll try to focus about how to obtain the expression in terms of gain with feedback, okay. So that's the overall expression. We'll be focusing on these mathematical steps in our next class, okay, fine. So I think we'll stop here. Just to summarize, what did we do today? We just looked at the 4 types of feedback connection types. Okay, voltage series, voltage parallel, current series, and current parallel feedbacks. Okay, all right. So any doubts? If there are any doubts, then let us discuss.